What is up, YouTube? This is Anonymous Mentor. Today I'm not going to be working out any C++ for you. I probably could make a video if you guys really want me to, showing examples of this, but as of right now, I'm just going to talk about the situation and hopefully you can get something out of it. And that's how to create random numbers in C++, because when you're dealing with computers and programming in general, there's usually an algorithm of some sort, and whenever you try, it's hard because whenever you put in a program or whenever you put an algorithm into a program, there's always going to be a pattern, an expected result, or certain numbers are going to be favored over others. So it's really hard to create random numbers, even though they may seem random. Um, with C++ in general, you can get buffer overflows, which means that every integer, every character, every string, every piece of your program has memory allocated to it, and you have binary, which is zeros and ones, on and off, basically, usually in bits of 8, and it can determine basically any number up to I forgot the exact number, but it's like 35,600 something or similar, something like that. But basically, what I'm trying to say is, let me get this out, get it. Um, in binary, you have 1, 2, 3, 4, 5, 6, 7, 8. You'll have like 8 bits. All right, and basically with these 8 bits is like if you have this right here, this first number right here means I believe 1, then it's 2, 4, 8, 16, 32, 64, so on and so forth. Now, since this is 2, that is 0, or I think it's 1, 2. So since 2 is on, your answer is 2, or this equals 2, because that's the only one that's on. 1, 2. Now, if you have this on, it's equal to 1. Now, if you have that on, it's equal to 3. You add the two together. So 1 and 2 is 3. It's something like that. I can't, it's been a while since I've done binaries, so if I'm explaining this wrong, just let me know in the comments. But basically, how the buffer overflow works is all of this, if all of them are equal to 1, and say your number, I'm drawing numbers out of the air here, say all that equals 36,000, all added together, okay? Now, if you typed into an algorithm to like multiply a lot of numbers over and over, and it's over 36,000, say your number is 36,001, you'll get a buffer overflow and the number will actually print out as 1. And in the case of buffer overflows in C++, you try to make an algorithm to where um, it'll break down and what seems like random numbers, because it always makes a new overflow, and that overflow can be any number because it ends in like maybe it's 36 point blah blah blah, and you take that and multiply it by 28, and then if you want it to be a number 1 through 100, you could tell it the modulus of 100, and it'll print out only numbers that are 36,001.3 blah 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 times 28 and divisible by 100. So, or it can divide into 100. 101 can't divide into 100 because it's more than 100, so it's not going to print out anything over 100. So, you have these buffer overflows that you can use that try to make it seem like random numbers, but in fact it's still not. So the one of the only ways that we have now to try and simulate randomness in programming is to grab the current time. So you'll grab whatever time is on someone's clock by minutes, hours, seconds, days. So for instance, say right now it's January 28th, 2013, 11:18 a.m. and 58 seconds. It'll take that number, you'll import it into the program, tell it to take that number, and then multiply it by that to try to simulate randomness, because that number is always changing. That number is never going to be the same, opposed to having a number like this. This number is always going to be the same. It's going to favor certain numbers. It's going to have a pattern to it. But if you have a number that's always changing, such as the time on someone's clock, it can help simulate randomness, because the number is never going to be the same, and it's hard to you can't really there is really no random numbers that you can generate in programming, period. It's all simulated. There is no randomness. So it's kind of a little discussion of how it happens. I hope my binary, I can't remember how it works, but it's similar to that. And if I explained it wrong, I'm sorry. Just go look at how binary works. But it's similar to that, and I was just using that as a point to try to explain how buffer overflows work. So like if you have something like that, because you entered in a number that was greater than as much as binary can handle. So binary can only hold eight bits that are all turned on. If you get 9 bits, it'll move over, and then it'll create a buffer overflow. It's something like that. I'm not quite sure. Don't quote me on it, but it's similar to that. So for now, if you're trying to generate random numbers, I would say pull out the date on someone's, use a function to pull the date, and then take that to create your randomized numbers, because otherwise it's really hard, because it's going to have patterns, it's going to have favoritism. So I mean, I hope this kind of helps. If you guys need me to make videos on it to show examples of pulling the date on someone's clock and then taking it and putting it through an algorithm to give you random number simulation, just leave it in the comments or send it to me in a message, and I will do that for you guys. This is Anonymous Mentor talking about random number simulation. Peace.